This video is to discuss example 16, where we are asked to create parallel box plots. So this is another one of the comparative plots, because when you make parallel box plots, they have to be on the same axis. So we have quantitative data here. We have still one variable and two groups. So all of these represent SAT scores. That's my one variable, but I have a group that took a prep class and a second group that did not take a prep class. So when we go to Staplet, we have to make sure that we choose one quantitative variable, multiple groups. That's the only way you're going to get your box plots on the same axes. Otherwise, it's going to draw you two separate axes, and that's not what you want. So I put SAT scores right here. I have prep group, I have non-prep group. I typed in all my data. Hopefully I typed it in correctly, and begin analysis. We start out with two dot plots. That's what it always defaults to. It's comparative because they are on the same axis. If you'll notice, they're identical, but we want to look at parallel box plots. So I choose box plot, and what I get is I get two box plots that are on the same axis. Okay, it's going to label it really well: SAT scores, prep group, non-prep group, but only if you type in that information. If you're going to cut and paste this into a document, it's really important that you remember all that good communication. Now, you will often now have questions that ask you to draw comparisons between these two. Okay, so you can definitely see things as you look at these box plots. I can see the median on the prep group is higher than the median on the non-prep group. So I can say that their measure of center is higher, maybe that their scores are somewhat higher in general. I can also very clearly see variability. Now, this group has probably a larger interquartile range, but this group has a much larger range. So there's a much greater variability, I would say, with the prep group than the non-prep group, okay? You can see the maximum, you can see the minimums for both. You can tell that neither group has any outliers. Okay, so I can talk about center. A lot of times on a box plot, it's kind of hard to talk about shape. All right, so if you're looking at shape, you're looking for a really stretchy part of the graph. So you see how this is really close to kind of the center of the box. And while this edge is a little longer than this one, okay, in the whiskers, it's not that big a deal. So this is probably, if I wanted to look at the histogram, pretty symmetric. Now, as I look at here, I'm seeing a lot more stretch on this end than this end, and I'm also seeing a lot more stretch in this part of the box than this one. So this, while it's not really, really skewed, may look a little bit more where my stretchiness is, maybe look a little bit more left skewed, okay? If you're having trouble assessing shape, change these to histograms, okay? I can see a lot better now that I may see a little bit of left skew here, and this looks almost more uniform, maybe also a little bit left skewed, but you can always change and look at a different graph for a minute if you're having trouble assessing shape from your box plot, okay? But what you see, as long as you support it, will work as far as that goes. Once again, if you've got to transfer this to paper, you can use a cutting tool and you can paste this into a document, okay? Or if you've got to copy it by hand, start by copying the axis first and then put the boxes on where they go, not vice versa, okay? Because you want this to be numbered consistently and you want these to be floating in about the right place. Thanks for watching example 15.